Before we get started on area, I thought it makes sense because there was a few people who were still having issues with their decimal numbers. So if you needed to, and you're still getting kind of that E or the exponential formatting, if you go to home and then you go to 5 for settings, and you go to 2 for document settings, and where it says float, I know I told you to put it on float, but if we put it on float 8, um, or whatever the highest one is. Float eight's usually fine, though. Float 10 will be fine as well. Essentially, floating is asking how many decimal places it wants to work with. So change it to float 10 or float 8 or something high, right? And if it's giving you something above like 10 decimal places, you probably need to work with it in a scientific format anyway. So changing it to float 10, that's a good place to start. Yeah, so if some people have already kind of stepped ahead and done a few of these, and that's completely fine if you remember them from the past. Just remembering too to make sure that you've started a new thing. If you haven't, you can always go over to the new document, hit one, and then start a new document, hit no to saving for your transformations table because we want to keep that fine for exams. Yeah, but otherwise, going down to your calculator, open up your calculator sheet because that's where you're going to do most of your math for this kind of section. Area formula is quite simple. If we're given a square, right, the area of a square is the length squared, right? So length times height or b squared, whichever way you want to do it. If it is a square, making sure it's either noted that it's a square, like it's written in the question that it's a square, or it's got those lines that indicate all four sides are the same. Right, continuing on for the rectangle, base times height, so we get the area of a rectangle. Just so like it makes sense if the base was 2 and the height was 1, right? That would be like split up like that. It'd be 2 times 1, which would give us 2, and there would be 2 squares. So that's how our square is set up, or our rectangle is set up. A trapezium, right? It's A plus B. Then that number divided by 2. So if A was 2 and this was 4, it'd be 6 divided by 2 multiplied by the perpendicular height. So perpendicular height meaning the distance between the two parallel sides, right? We're going to get that perpendicular height here. We're going to use that in triangles as well. So area for parallelograms, base times height, and that's all it is. It's essentially the same as a rectangle. Before we get onto squares, I think it says find the area of this quadrilateral below. So first of all, I've got to identify what type of shape is it. What type of shape is it? Trapezium, yep. So we go to trapezium. We're using this formula. We're using our area is equal to A plus B in brackets because we do that first, divided by 2, multiplied by height. If I want to actually write that down in steps, I could label it. This will be my A, this will be my B. Because we're adding them together, it doesn't actually matter if you do it B or A or B, whichever way you want to do it. And then our height, what's our height for this situation? 7, yep, so that's our H. So then we use that and supplement everything in, everything in. A is 6 plus 16 divided by 2 times 7, right? We could work probably a few of these steps out in our head, but 6 plus 16 is what? 22 over 2 times 7. What's 22 divided by 2? Yep, A equals 11 times 7. What's 11 times 7? 77. Yep. You see, if you can do these things, you don't even need to touch your calculator, right? But you could have skipped it. You could have done the whole thing on your CAS. But one thing to note is you probably would have needed to make sure you do the, so on the CAS, you could just do the whole thing. Make sure you're doing the 6 plus 16 with brackets, which I didn't actually write down there. So to do it on your CAS, making sure you're using the 2 spots, so control, and then where's the division button is, you can do the little fraction, bracket for the top bit, sorry, that's not the bracket for the top bit, and then going 6 plus 16, close your bracket, go down, divided by 2 times 7, right? And big maths, our calculators actually do that, but noting that the division or multiplication, whatever's first, so doing this here first makes sense. Probably make sure that's on that side, although it shouldn't affect you. So 77 on the CAS, able to do that there. If you did that in a test or in the exam, just taking note that if it's a 2-mark question, it's probably asking for you to actually do the formula as well, right? Before the substitution. All the working. So if you'd done it on the CAS, like you would write it out like this and this, or just this, right? And then got the working out here, and then writing CAS, arrow, area equals 77. What am I missing here from my answer? Yeah, the unit. So whenever it's not described what it is, it's not in the question, it's not on the shape. We actually need to say units squared, right? So we're working with area, it's a unit squared. Does it?
Yeah, it says centimeters.
Ah, in centimeters, sorry. So it's not units. Thank you very much. Centimeters squared, and apologies, Mel. Good observation. Centimeters squared. All right, area of the circle and sectors. So for the area of a circle, the amount of space inside a 2D shape, the way we work out area is pi times the radius squared. Right, so whatever this is squared multiplied by pi. If for some reason you're stuck and you can't find the pi button, it is right down there, right? So we hit that and it brings up a list of options. Pi is the first one, so you just hit that and enter, and then we won't work with the rest of them. If you're working for a sector, the sector is going to give you this angle here, right? It is just that angle divided by 360 multiplied by pi multiplied by r squared. So essentially this multiplied by that, right? So if this angle was 42, it'd be 42 divided by 360 multiplied by the actual area of that full circle. All right, moving on. We've got two to do here. So this first one, what is our R value for this? It is 4, right? Noting that we've got diameter equals 8, so R equals 4. Right, so for our formula pi r squared, we need to go through and do pi times 4 squared, just on your calculator, nice and easy. Pi 4 squared. You don't have to do the times in between. Enter. Is that light on? So, yeah, there we are. 16 times n, so that's going to not give us 16 times pi. I'm not quite sure what's popping up for that. It'll be something in the settings that I'll find out. But if you hit the equivalent button, so I think it might be on exact this calculator, just hitting the control and then the equivalent equal sign like we were doing from our fractions, it gives us the actual measurement there. So 50.256, that would be our circle. If so 50.265 in measurement, you could probably still always refer to 2 decimal places. I would almost always write this in almost its full. So what's 2548 millimeters squared, and then I would probably round it to 2 decimal places, 50.27 millimeters squared. For the sector, right? The sector one, the first thing we've got to do is work out the area of the full circle. So it's 13 because that's our R. So pi r squared is going to be 13, and it does it. So pi times 13 squared equals, and it does want me to do that thing again. So that part equals 530.929. We could probably plug the whole formula in at this point as well. So if you wanted to skip this step, we could just do it as the way it kind of goes through. So we want the this over 360, so the angle over 360, adding in a thing. So it's 140 divided by 360. To make sure that happens first, we can put that in a bracket if we like. 140 over 360 multiplied by pi, and then our 13 squared. It's giving me a fraction. I'm going to have to do that button again. So 206. So the whole thing in our CAS gives me 206.472. Let's go 5. It's in centimeters, so centimeters squared. Rounding that, so 206.47 centimeters squared. And just noting, right, this shape looks like about a third of it. 200 is close to a third. It's probably closer to half of 530, but it's in the right ballpark. So we're able to kind of eliminate any doubt that might have been the wrong thing. Moving on to triangles. Triangles, this is all pretty much revision too. I'm sure you guys have done this stuff before. So base times height for triangles. When it's a triangle on an angle like this, we want to go off the height from the right angle, right? So perpendicular height from the lowest base up to the highest point. That h is going to become quite important. We're going to need to find that. Um, area is half times base times height. So essentially, base times height gives us the size of a rectangle or a parallelogram. And then we're halving that because if we double any triangle, like flip it and translate it, it's going to equal that same kind of shape. Alternatively, the side lengths are known as area can be found using. All right, so you might specifically be asked to use Heron's formula. So when all three side lengths are known, but not the height. So if we were giving all of these side lengths, but not the perpendicular height, there is a formula we can use to do it. Looks a bit of a chunk, but it's not too bad, right? So where S is equal to A plus B plus C divided by 2. So all of the lengths added together and then divided by 2. And then we're just going to use that S over and over and over, right? So that value over and over. We'll do that across the board because this one here, do we have the perpendicular height? Yep. What's the height of this? Yeah, we're given the height, so let's just use it. So in this case, we've got area is equal to 1/2 times base times height. In this equation, area would be equal to 1/2 times 3 times 9.89. And we can just put that in our calculator nice and simply. Half, what's another way of writing half? Yep, so 0.5, we can put that in there if we don't want to do our fraction, save ourselves a few clicks. So 0.5 times 3 times 9.89, 9.89, enter. Yeah, mine's definitely not the right settings. Gives us 14 point area equals 14.835. That's centimeters squared. That's our area of the triangle for that one. If I move over to the next page, we've got a triangle that has all three side lengths. So I've kind of got two band references here, which is handy for me. I can put that there. We've got Heron's formula here. So the first thing that we want to do is we want to work out what S is equal to. S equals A plus B plus C over 2. So 6 plus 6 plus 2. 6 plus 6 plus 2 divided by 2. Right, what's 6 plus 6? Yep, plus 2. 14 over 2. What's 14 divided by 2? 7. Perfect. So we know our S value is 7. Right, so we can kind of work that out. Now we're going to do Heron's formula. So that's area equals the square root of S. S take A, then S times S take B. And you might not want to write this whole step out, but S take C. For the sake of doing it, I am. So each A, B, C referred to one of the side lengths. So we did it as A, B, and C. Right, so area is equal to, and I would just put this in your calculator if to save yourself time. So S is going to be 7. So first of all, we do the square root, control, and then going where it's the square button, gives you the square root. We're going to do 7 multiplied by, so do the bracket, S, so 7 take away 6, 7 take 6, close the bracket, another bracket is going to be 7 take 6 again, then close the bracket, another bracket, it's going to be 7 take 2, right, hit enter on that. Same with the square root of 35, get the approximate value, is going to give me 5.9, 5.916, 1, just do that, and then rounded, area equals 5.92 centimeters squared. Does that make plenty of sense so far? So Heron's formula is only when we've got three sides and we don't know the height. It seems a bit tricky, but like in my calculator, realistically, I could work out what 7 take 6 is 1, 7 take 6 is 1, 7 take 2 is 5. We're just doing 7 times 1 times 1 times 5, and then doing the square root of that, right? So it seems complicated, but it's just a bit of like pushing stuff through. The answer is fine. If you were skipping writing out the whole formula, right, just make sure you note somewhere that you used Heron's on CAS or something like that. So it saves you a little bit of time. Cool. Moving on to the area of composite shapes. Man, this video has gone for a long time. Am I talking slower today? Should. Oh, really? Okay, slow it down for everybody. For the sake of it being a shorter YouTube video, I'm going to stop it and start it again, okay?